In this video, we're going to talk about how do you sketch the graph of a polynomial. So we're going to be given a polynomial like we have here. This polynomial, notice, is in factored form. Okay, if we were to multiply all this out, it would turn out that this would be a polynomial. I'll do that at the end of the video. But we're given a polynomial here. How do we graph it? And notice this is not a multiple choice question. I'm not asking you to pick from amongst many graphs here. How would we graph this just from scratch? Okay, well, one thing we could look at are what are the zeros. Okay, what are the zeros of this function? In other words, what numbers can you plug in for x that would give you an output of 0? Okay, for example, maybe you think that the number 8 would give you an output of 0. So the question is, what's f of 8? Is it going to be 0? Well, if you plugged in 8, this would be 10, and then times, well, this would be 7. And if you plugged 8 in here, this would be 3. Well, is 10 times 7 times 3, is that 0? No, of course not. So 8 is not a 0. So what numbers can you plug in for x that would give you an output of 0? Notice that -2 is an example, because if you plugged in -2 everywhere you see an x, well, you would get 0 in this first factor. Now these other factors would be whatever they are. I think it'd be -3 and -7. But 0 times whatever these are, it would be 0. Now another 0 is the number 1. Because if you plugged in 1, what's f of 1? Well, if you plugged in 1 here, it would be 3. If you plugged in 1 here, it would be -4. But if you plug in 1 there, it's 0. So 0 times whatever these other ones are, it ends up being 0. And finally, 5 will also be a 0. Okay, so these three numbers are the zeros of the function. And it turns out the zeros of the function, remember, are really the x-intercepts of the graph. So this one is going to cross the x-axis at -2, 0, at 1, 0, and at 5, 0. Now I'm not making all the tick marks here, but because when we plugged in 5 we get an output of 0, that means this point 5, 0 is on the graph. 1, 0 will be on the graph, and -2, 0 will be on the graph. So our polynomial is going to go through these 3 points, but the question is, what does the rest of the polynomial look like? Well, notice if we take a number between 1 and 5, okay, just pick any number between 1 and 5, the question is, are we going to get a positive number or are we going to get a negative number as a result? If we get a positive number, our graph is going to be above the x-axis. If we get a negative number, our graph will be below the x-axis. So for example, let's pick a test point. So some point between 1 and 5. Let's try 3. Okay, if we plugged in 3, notice we would get 5 times 2 times -2, I believe. Yeah. Okay, and what's 5 times 2 times -2? That's 10 times -2. That's -20. So if we plug in 3, we'd be down here at 3, -20. It's way down here, right? If we're over here at 3, it'd be at -20. The point is, if you take any number between 1 and 5, I just picked 3, but if we take any number, we're going to be below the x-axis. Okay, the graph will be below. Now, if it's below for one number, it'll have to be below for all numbers because we're never crossing the x-axis anywhere in between 1 and 5. Now, if we take a number that's bigger than 5, so let's take 6. Okay, the question is, are we going to be up here, or maybe is the graph going to bounce off that point and we're going to end up down here? Well, if you plug in 6, you would get 8, right? 6 plus 2 is 8, times 5 times 1. Right? If we plug in 6 there, we get 8 times 5 times 1. And notice that's 40. Okay, so the point 6, 40, which is way up here, is going to be on the graph. And it's going to turn out the graph is going to go up like this. And now it's not going to ever come back down because we don't cross the x-axis anymore. Okay, now what if we take a number between -2 and 1? So pick any number between -2 and 1. Let's just take 0. If you plug in 0 everywhere you see an x, you're going to get 2 times -1 times -5. Okay, we're just plugging in 0 for x, and notice that would be +10. Okay, so this is going to go through at 0, +10. It's going to be up here. So the graph is above the x-axis between these 2 points. Okay, and if you take a number that's less than -2, so let's try f of -3. Well, we would get -1 times -4 times -8. Okay, if we plug in -3, we get -1 times -4 times -8, and that ends up being -32. Now, why negative? Well, because we have 3 negatives, it ends up being a negative. So if we plugged in 3, we'd be way down here at -32. So the graph the basic shape of the graph is going to look like this. Now, if you tried graphing this on a graphing calculator, you'd have a little bit of trouble because notice these numbers way down here and here, they're very big numbers. So if you tried to graph this on a graphing calculator, the issue would be you'd have to get the correct viewing window on your graphing calculator. But this is the basic shape of the graph. Okay, now I also mentioned here at the beginning, is this really a polynomial? Okay, is that really a polynomial? Well, if we were to multiply out f of x equals, again, let's get it here, x plus 2 times x minus 1 times x minus 5, is that really a polynomial? Well, let's actually multiply these together. Let's multiply x plus 2 times x minus 1 first. Well, x times x is x squared. We're just FOILing this out. If you multiply the two outside terms, you get negative x. If you multiply the two inside terms, you get positive 2x, so that would really be like a plus x. And finally, multiply the two last terms, you get a minus 2. Okay, so if we FOIL this out, we get this. But we still have to multiply it by x minus 5. So how do we multiply it by x minus 5? Well, we're going to take each term in here and multiply it by x, and then each term and we'll multiply it by minus 5. So let's multiply x squared times x, and actually I can get rid of this parenthesis here. Let's multiply x squared times x, we get x cubed. Let's multiply x times x, we get x squared. And minus 2 times x, we get minus 2x. So I multiplied each of these terms by x. Now I'm going to multiply each of these terms by minus 5. So x squared times minus 5 would be minus 5x squared. X times minus 5 would be minus 5x. And finally, minus 2 times minus 5 is plus 10. Now let's combine our like terms. The only x cubed we have is the first one. We have an x squared and a minus 5x squared. That's really minus 4x squared. We also have a minus 2x and a minus 5x. That gives you minus 7x. And we also have that plus 10. So actually, if you multiply all three of these together, it turns out you get this, and you can clearly see this is a polynomial. In fact, it's a third degree polynomial. X cubed minus 4x squared minus 7x plus 10. Okay, well, you don't need to do this last part in order to do the problem. Okay, to do this original problem, sketching the graph, we just had to find the zeros of the function, and we plotted those as the x-intercepts, and we had to decide on each of these intervals. Okay, this first interval here, the second interval between minus 2 and 1, the third interval between minus 1 and 5, and the last interval after 5 here is the graph above or below the x-axis. Okay, and that's what we did.